Alright, so I'm going to show you guys a quick, factoring a trinomial or anything. You could factor a binomial. You want to see what the common factors are. And in this, I can see I have two terms here. And the common factors, if I look at it like this is 2 times x, and this one is 2 times 3 times x. So you don't have to do all this work to do this, but this will show you why or how, the basics of it. So both terms have something similar in them. So if I look at this like this, I can see this first term has a 2 in it, and the second term has a 2 in it. So I can divide 2 or factor 2 out of both of those terms. And both terms also have an x in them. So I can also factor that x outside. So it looks like this. We basically make a parenthesis. We usually jump from this step to this step, where I would factor a 2 out and an x out because I recognize that they can be factored out. And I think about what's left in the two terms. The first one will be an x because 2x times x is 2x squared. And the second term will have a 3 because 3 times 2x, or 2x times 3, is 6x. So these are equivalent, but this is the factored form. And we just double check that we can't continue to factor it anymore. And I see I have three factors here, if you want to call 2 a factor, x a factor, and the parenthesis a factor. And so also you could have something like let's do a double one. 2x squared plus 14x plus 24. So if I had something like that and I wanted to factor that, 2x squared plus 14x plus 24, the first thing I always need to look for to factor that is, are there any common factors? And I kind of see that 2 times 7, 2 times 12, so 2 can factor out of that. What's left over when I take the 2 out? When I divide the 2 out or factor it out, I have x squared plus 7x plus 2 times 12 is 24. Yep. And then I continue to factor it because it's not complete yet. I think I can factor that trinomial into 2 binomials. And I know I'm right if I can find 2 numbers that multiply together to give me positive 12. I can make a little table. 1 times 12. 2 times 6. 3 times 4. Which one of these pairs adds up to 7? The middle number. The 7 right here. Which one of those pairs adds up to that 7? And if I look carefully, I can say, well, the 3 and the 4. 3 plus 4 is 7. So 3 and 4. And I'm done. I factored it into 3 factors. If I multiply the 2 back in there, and then I multiply the answer by the other binomial, or if I do the FOIL with the 2 binomials and then multiply everything by 2, I should get that. Okay, so that's the factoring piece. The other thing we did was some completing the square. What if I had something like this? Half of that's 16. If I had that and I said, hey, can you put this in vertex form? If I had this f of x equals that. Can I put that in vertex form? Heck yeah, I can. The function is boom, boom, because that's already a perfect square trinomial. I know that because I know that half of that 8 is 4. And when I square the 4, I would get 16. And it's already there. So I know that I can keep the first term, the sign, and the last term's square root, because I square rooted x squared to get x, so I square root 16 to get 4, and you're done. Okay, x plus 4 squared. Sometimes we have something like this. Now we know when we have an 8 there that we really want a 16 here, but what if I had only a 15 there or something different? Then I can't just put it in vertex form. It's not a perfect square trinomial. But I can look at just these first two and say, hey, really what I want here is a 16 to be over here. But I can't just like add 16 to this stupid thing. So if I added 16, I'm going to take the 16 away. That's like you didn't even change anything. Now this first part we know is x plus 4 squared. And this other part here is a 15 and a minus 16 is a negative 1. And that is your function f of x in vertex form. And your vertex is hk, where the parabola is going to have its minimum or maximum is negative 4 and negative 1. Yay.